Alright, this integrity session represents our last in our series of sessions that we're using to review for the Math 098 readiness test. Sessions have already been completed regarding Test A through C, which covers solving equations in Test A. Test B was on adding, subtracting, multiplying polynomials, and Test D was dedicated toward factoring polynomials. So now with this current review, we'll be looking at graphing, in particular linear equations. Alright, now the first set of problems that we see here, 1 through 5, ask to graph the linear equations by using a T-chart. At least 3 points must be identified for full credit. Alright, so the main thing we want to know is when we're using a T-chart, for all of these problems, you want to solve for y. That's the key. Alright, so for these problems where they're asking you to use a T-chart, you want to solve for y. And in particular, you want to solve for y such that y is isolated, and then any x term you may have is written before any constant term that you have. So y equals mx plus b is the format that we're really going for. Alright, for all 5 of these problems. Okay, so the first problem, we see that we have 3x minus 2y equals 4. So to get y by itself, we would have to subtract 3x from both sides. That would give me a negative 2y equals, now notice I'm writing a negative 3x before I write the positive 4. Alright, you see here on this side I have 4 minus 3x, but these are not like terms, and because they're not like terms I can't combine them, so I have to write them out side by side. But notice I write the negative 3x first before I write the 4, because as I said up here, you want to get y by itself where you have the x term on the other side written before you write the constant term. Okay, and this being a constant term. So that's why we're in this format that we're in right now. Alright, still trying to get y by itself. Now we divide everything by the negative 2. That cancels. Negative 2 here, negative 2 here. Alright, so now we have our y equals. Now notice, we have a negative 3 over a negative 2. Negative over a negative when we're talking division gives us a positive. So we rewrite it as a positive 3 over 2x. And now we have 4 divided by a negative 2, which gives us a negative 2 for an answer. Okay, so now we have our format. Y equals m, which is a 3 over 2, which is referred to as slope. Y equals m, x, and here's our b. This negative 2 is our b, which we refer to as our y-intercept, where the line would cross the y-axis. Okay, so we've solved for y. So now the second part is to actually form the T-chart that they're asking for. Okay, so to actually find this T-chart that they're asking for, so we're making our T-chart. Basically all we're doing, x on one side, y on the other. And know that when you're making T-charts, you have the freedom to choose any set of x values that you'd like. So any 3, since they want 3 points, you can pick any 3 x values you like. Now here's the thing. Typically I would tell my students to use -1, 0, and +1 because those are the 3 easiest numbers to work with. However, anytime my slope is a fraction, I advocate that instead of using a -1 and a +1, that instead when my slope is a fraction, I use the negative and positive version of the denominator of that fraction. So instead of using a -1 and a +1, I'm going to want to use a -2 and a +2, again because my slope is a fraction and the denominator of that fraction is a 2. So that's why I'm using a -2 and a +2. And the reason being is because I'm going to plug these values here in for x, in right here for x, and multiply by this 3/2. And when I use these 2's, whether it be the -2 or the +2, is going to allow me to get rid of this fraction. I know most students are more comfortable with problems that don't include fractions. So this allows us the means by which to rid ourselves of the fraction on the front end. Okay? So now if we're using a -2, 0, and +2, and again, we always want to use 0 if we can in the middle. So -2, 0, +2, plug in my -2, so what I'm really looking at is y equals 3 over 2, and x is now -2 minus 2. Okay, so now I'm looking at this -2 right here. So that -2 times this 3 is -6. Okay, so now you say y equals -6 over 2 minus the 2, right? Because the -2 just comes down. -3 times 2 gives a -6. Now you got a -6 over 2. Well, -6 over 2 is the same as saying y equals -3, and you still got your -2. Alright, so y equals a -3 minus 2, which equals a -5. So y equals -5 when you plug in a -2 for x. So when x is -2, y is -5. So now you do the same thing, plug in a 0 for x. So y equals 3 over 2 times 0 minus 2. And we know 0 times anything is just 0, so we can just cancel all of that, and you're stuck with y equals -2. So you have that, and now we're going to go with the +2 being plugged in. So y equals 3 over 2 times 2 minus 2. 3 times 2 is 6. Okay, across the top, 3 times 2 is 6. 6 divided by the 2 on bottom is a 3. So now we have y equals 3 minus 2, which is 1. And if you notice, because there is a pattern because our x inputs are symmetric about 0, so we have 0 and we have -2 and 0 and +2, because it's symmetric on the x side about 0, we should always have a pattern with our y values as long as we're dealing with linear equations. So if you notice, we got a -5 for the first answer, and then if I added 3 to that, I'd get a -2 for an answer. And if I add 3 to -2, I'd get a +1 for an answer. So the pattern that we see here is increasing by 3. Okay, so the y values, if we follow the pattern on the x side, so if the next number was a 4 on the x side, then we'd have a 4 over here on the y. Okay, alright, so now we have 3 points. If you notice, that's a point, that's a point, that's a point. So now we can form our graph, and on your test you will actually be given a graph, so it won't be so much of a problem. Now notice, when I'm making this graph here, I'm making sure I have 5 hashes on each axis, x-axis, y-axis. I'm making sure I have 5 hashes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm making sure I have 5 because when I look at my set of points, the biggest number, when we think in absolute terms, absolute value terms, the biggest number out of all of these is this 5 right here. Even though it's negative, that's the biggest or farthest distance from 0. Okay, so since 5 is the biggest number out of all the numbers in my 3 sets of points, I want to make sure my graph would have 5 hashes. Alright, so the first point is going to be this -2, -5. X is -2, y is -5. So from my origin, which is right here in the middle at 0, 0, I'm going to count left 2. That's my x is -2. Then I'm going to count up 1, 2, 3, 4, 5. And so my first point would go about right there. Okay, and that's my -2, -5. Oops, excuse me, it's a -5. Scratch that, should go down instead of up. So my -2, negative 2, down 5. So it's over here. So I went from the origin, I went left 2, then I went down 5. So there's my first point. So now I have 0, negative 2. So from my origin, x is 0. So I don't go right, I don't go left, because x is 0. So I stay here in the middle. Now y is 2, is negative 2. So I come down to 2. There's my point there. And then I have 2, 1. So from the origin, I go right 1, 2. I go up 1 and make that point. And basically I'm looking at a line that looks like this. Alright. So there you have it. Your T-chart and your graph. So there's your answer for that one. Again, all of these problems we're solving for y, and we're forming our T-chart. Okay. Now, if we look at number 2, notice number 2 is already in the form we want, so we don't have to solve for y. It's already solved for y. Y is already by itself in the positive form. So we can go straight to forming our T-chart, x and y. Now notice, once again, our slope, our m, is a fraction. This time 3 is in the denominator, so I'm going to use a negative 3, 0, and a positive 3 for my T-chart because it is 3 in the denominator. Alright, so y equals negative 2 times negative 3, because x is negative 3, over 3 plus 1. Alright, so a negative 2 times the negative 3 is a positive 6. 6 divided by 3 is 2. 2 plus 1 is 3. So when I plug in a negative 3, the answer is 3. Then when I go with a 0, now I'm going to plug in a 0 because that's my second value of x. 0 times anything is 0, so all that cancels, and you're just left with y equals this 1 over here. So you have that. And then lastly, I'm going to plug in a positive 3. Positive 3 times a negative 2 is a negative 6. Negative 6 divided by 3 is a negative 2. Negative 2 plus 1 is a negative 1. Negative 2 plus 1 is a negative 1. Alright, so now again I have my 3 points. There's 1 point, 2 points, 3 points. And when I look at my points, 3 is the biggest number, so I need to make sure my graph just has 3 hashes. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And again, your answer sheet for your test should have grids on it, so you won't have to worry about making your own graphs. But for the purpose of helping you with this, I have to do that here. So negative 3, positive 3, which is our first point. Negative 3 is left 3, positive 3, up 3. So there's the first point. 0, 1 here. There's 0, 1. X is 0, so I don't go right, don't go left. Y is 1, so I went up 1. Alright, and then the last point is 3, so x is 3, go right 3, and then 1, y is 1, so down 1. So that's about right there. And so my line, I connect the dots, is going to be something that looks about like that. Okay, there's that one. Alright, look at the next one. Number 3, solving for y. So I'm going to subtract 2x from both sides. So I have 5y equals negative 2x plus 5. Again, these right here are not like terms over here, so I have to write them out. And I'm always going to write the x term before I write the constant term when I'm doing graphing. So now I'm going to divide everything by 5. Divide by 5, divide by 5, divide by 5, cancel. So now I have y equals negative 2 over 5 x plus 1, because 5 over 5 cancels and just becomes 1. So we've solved for y. We have our base equation here. Now we're ready to make our t-chart. Again, our slope, our m, is a fraction, so we're going to make our x values be centered around that 5 in the denominator. So -5, 0, +5. Okay, so when x is a -5, so when x is a -5, then -5 times a -2, there's a -2 here, so -5 times -2 is a +10. 10 divided by 5 is 2. 2 plus 1 is 3. Remember, 0 times anything is 0, so y just be 1. Plug in a 5. 5 times a -2. 5 times -2 is -10. -10 divided by the 5 on bottom is a -2. -2 plus 1 is -1. So we have our 3 points. 5 being the biggest number out of all of these, or the greatest distance from 0, is maybe a better way to put it, absolute value wise. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. Okay, so -5 back here, up 3. 5 up 3, so right about in here somewhere. 0, 1 here. 5, -1 here. And so our line, I know it's crooked, but our line will look something like that right there. Alright, there's that line. Okay, now moving on to the next problem. Again, we're solving for y, so plus 6x plus 6x, so we have -6y equals 6x plus 0. So since the 0 is over there, there's no need to writing it. Now we're going to divide both sides by -6, so you have y equals a -1x, which is just written as a -x. Y equals -x. So now for the first time, we're not dealing with a slope or m that's a fraction, because our m in this case is really like saying there's a -1 right there. That's really what we're looking at. So now we're dealing with an integer for a slope. And anytime we have an integer for a slope, it's easy to just use -1, 0, and +1. For any integer, it's easiest just to use -1, 0, and +1. Okay? So if x is -1, -1 times -1 is +1. If x is 0, 0 times anything is 0. And if x is +1, +1 times a -1 is a -1. 1 being our greatest absolute value out of our 3 points. So real easy to graph. 1, 1, 1, 1. So -1, 0, -1 plus 1, 0, 0, and over 1 down 1. And so this one very easy to graph. Alright, and then we have 5, our last one. Again, trying to solve for y, so we're going to add 1/2 x to both sides. That cancels over here. These are not like terms, so we write it out. So you have -y. Remember, you still got this negative right here. So this is -y equals 1/2 x minus 3. 1/2 x minus 3. Now we don't like this negative, so to get rid of this negative would be like dividing everything by a -1 or multiplying everything by a -1, whichever you prefer. But at the end of the day, all it means is change all your signs. So now what we really have is this. After we change all the signs, y was negative, now it's positive. Our slope, which is 1/2, was positive, now it's negative. Our y-intercept, which is a -3, it was negative, now it's positive. Okay, so this is the equation we're working with now. And once again, we have a fraction, and so we're going to use 2 to form our x values. So -2, 0, +2. When x is a -2, -2 times a -1 is a +2. +2 divided by 2 is 1. 1 plus 3 is 4. 0 times anything is 0. 0 plus 3 is 3. 2 times the -1 is -2. -2 divided by 2 is a -1. -1 plus 3 is a +2. And if you notice, we have our 3 points. And just like as I've said earlier, your y side should fit a pattern. Here it's all a difference of 1 from answer to answer. Same here, a difference of 1 from answer to answer. So it's fitting a pattern. Okay, so as long as you're fitting a pattern over there on that y side, feel pretty good about your answer. Not saying it's going to always be right, but at least you should feel like you're on the right track for the most part. Okay, so now we look at our 3 points, our greatest absolute value being 4, so we need to make sure we have 4. Alright, so -2, 4 is somewhere up here, 0, 3 is here, 2, 2 is there. So there's your line. Alright, so the thing about 1 through 5 is you have to use the T-chart. So you have to go about it using this particular method that I've shown. Alright, again, there are other methods of graphing, but they specifically want you to use a T-chart, so that's why we've chosen this particular method to perform or to display our graphing for all 5 of these equations. Okay, let's see. I'll scroll down for the remainder of our problems. Alright, problem number 6 and 7. Find the slope and y-intercept, if any, for each equation. So once again, for these 2 problems, once again, solve for, I know this pen, I'm making it look kind of ugly, but solve for y. Y equals mx plus b. Okay, solving for y once again. Alright, so we want to get y by itself. So here, number 6, let's subtract 9x from both sides. So we have 7y equals -9x. Okay, -9x minus 14. Divide everything by 7. So now you have those cancel. Y equals -9 over 7. X minus 2. Minus 2 because 14 divided by 7 is 2. So that's where this -2 comes from. Okay, so now we have our form, and they ask for our slope. So our slope is our m. So this would be our slope. Okay, that's our slope, -9 over 7. And our y-intercept is this -2. Our y-intercept, which is our b, is that -2. So there are the answers to problem number 6. Okay. Problem number 7, y equals -5. Notice, for one, this problem is already solved for y, and 2, there's only one variable present. There is no x in this problem, it's just a y. And what I tell my students is, anytime you have an equation and you're graphing linear equations and you only have one variable, then you're going to have either a vertical or a horizontal line. Now, whatever variable is present, your vertical or horizontal line is going to touch that axis. So since we're dealing with the y variable, that means whatever line we draw, horizontal or vertical, is going to have to touch the y-axis. So if we think about it, if this is the x-axis and the y-axis, and the line we're going to draw is vertical or horizontal, but it's got to touch the y-axis, the only way we're going to touch the y-axis is if we make a horizontal line at -5. So we would say this down here, we just say that that would be -5 on the y-axis. Okay, so that's what it would look like graph. Now, they didn't ask you to graph it, okay, but this helps us kind of put everything in perspective. So we know our slope is rise over run. Now, if we know that this right here is the line that we get from y equals -5, then we ask ourselves, first, if we're trying to find our slope, we need to look for rise. So we can pick any point anywhere on this line. Say we pick the point right here on this line. Can I rise up or fall down? Can I rise up or fall down from this point and still be on this line? And the answer is no. And I don't care what point on this line you pick. If you pick the point right here, if you went up, you're off the line. If you went down, you're off the line. So when it comes to rise, you can't get anything. So that's 0. Now, you go back to any of these points again, and you talk about run. Well, run is the x-axis, so run is side to side. So if I'm at any of these points, let's say this point right here, if I'm here and I decided to go right, I'm still on the line. If I'm here and I decide to go left, I'm still on the line. Let's look at this point. Here, decide to go right, still on the line. Decide to go left, still on the line. So for run, doesn't matter what point I choose. If I go right or left, I'm still going to be on this line. So I know for run, I will get some kind of value. So anytime I have 0 over some value, the answer will be 0. So in this case, my slope is 0. Okay? Now, as far as y-intercept is concerned, y-intercept simply says, where is the line going to touch the y-axis? Well, we see this line is touching the y-axis right here at -5. So my B is -5, which is my y-intercept. So that would be my answer to that. Okay? So my slope would be 0 and my y-intercept would be -5. Alright. Moving on, number 8. Find the slope of a line through the given points. Okay. So if we're given 2 points and we want to find the slope, there's a very easy formula that you can plug into to get that. And that formula is y2 minus y1 over x2 minus x1. Okay, where if you're looking at these 2 points here, if this is our first point, then that makes this 6 our first x and this -11 our first y. If this is our second point, that makes this -3 our second x and this -6 our second y. So all I would do is take these numbers and plug them in over here into our formula. So y2 would be a -6 minus my y1 is -11 over, and notice this minus sign right here is part of the formula right there. Okay, now x2 on the bottom, which is my -3 minus again, this minus sign is part of the formula, minus my x1, which is just 6. So I notice here I have double signs. Those two signs combine to form one positive sign. So negative 6 plus 11 gives me, what is that, 5. 5 up top, excuse me, and on the bottom negative 3 minus 6, which would give me a negative 9. So slope is a negative 5/9. So there's your answer for number 8. Okay, number 9. Let's erase. Number 9 now is asking for x and y intercepts. Find x and y intercepts. Now, anytime you're asked for both intercepts, that should be your clue to get both of the variables together on the same side. So what you're really looking to do with these is to get the equations in this form, where the x and the y are now on the same side, where the constant term is on the other side of the equation by itself. Okay, now one of the big keys to getting the equations in this form is that we don't like fractions. No fractions, and that should be good news to the students, because most of them don't like dealing with fractions anyway. Okay, so in order to looking at problem number 9, we see we have a fraction here in the way of negative 5/6 x. So if we ever presented with an issue like that where we're needing to get rid of the fraction, then we can simply multiply the entire equation by that common denominator, which in this case is 6. So I'll have y equals negative 5/6 minus 5, and I want to get rid of the fraction, then I simply multiply everything by that denominator, which is 6. So 6y equals negative 5x minus 30. Okay, so now I've gotten rid of the fractions. So now once the fractions are gone, I can move my x over here with my y. So my equation is in form. I have my x and my y on the same side, my constant over here on the other side of the equation by itself. At this time, I find my x-intercept by making y 0. So if y is 0, I'm really looking at 5x plus 6 times 0 equals negative 30. And then for my y-intercept, x will be 0, so I can find a y. So if my x is 0, I'm really looking at is 5 times 0 plus 6y equals negative 30. Now, for the x-intercept, 0 times anything is just 0, so that'll cancel, and you're left with 5x equals negative 30. So divide both sides by 5. X would equal negative 6. So your x-intercept would be negative 6, 0. Alright, now over here for your y-intercept, you're making x 0, and 0 times anything, like we said, cancels. So you're really left with 6y equals negative 30. Divide both sides by the 6, y equals negative 5. So 0, negative 5 would be your y-intercept. So x-intercept would be this, negative 6, 0. Y-intercept would be 0, negative 5. Okay? Number 10, the equation is already in form for us. So all we have to do is find our intercepts. So first we'll find our x-intercept. So 4x equals a negative 8. Notice I didn't write the 9y. I didn't write the 9y because for x-intercept, y would be 0, and 0 times this 9 would be 0. So this 9y then would disappear for the x-intercept. So that's why I just wrote the 4x and the negative 8. Divide both sides by 4. X equals negative 2. Negative 2, 0 would be my x-intercept. Y-intercept now. Alright, looking back at our equation, y-intercept, we're going to make x 0. So if this x over here is 0, 0 times 4 would give me a 0. So now that's disappearing. That 4x is disappearing. So all I'm going to be left with is this 9y equals a negative 8. Divide both sides by 9. Y equals a negative 8 over 9, which would be like saying 0 and negative 8/9. And that would be your y-intercept. And it's fine to leave it in fractional form like this. You don't necessarily have to transform this into a decimal or convert it to a decimal. Okay, so that's our x and y intercepts. And then lastly, number 11, tell whether you're parallel, perpendicular, or neither. Okay, now before we get into before we get into how to solve it, we want to talk about what they mean. Parallel, which usually means two lines running side by side, so like a real skinny 11, a symbol for parallel, means that the slope of one line is going to be the same as the slope of another line. Okay, so if I had an equation 2/3 x minus 5, and I had another equation, alright, notice these two equations are a little bit different because the y-intercepts are different. Alright, so they're two different lines, two different equations. However, these two equations, these two lines would be considered parallel because the slopes are the exact same. The slope here is the exact same as the slope is here, and I mean the exact same. Signs, everything is the exact same. So the slope in equation 1 is 2/3, and the slope in equation 2 is 2/3. So slope of 1 is equal to slope of 2. That's what it means to be parallel. Now, perpendicular on the other hand, which is like an upside down T, which is saying two lines are crossing to form a right angle or a 90-degree angle. It's saying that my second slope is going to be the negative inverse of my first slope. Okay, sounds complicated, but really all it means is I'm going to flip and change the sign. Okay, so notice, let's take our y equals 2/3 x minus 5. So let's take our equation 1 again. Now for equation 2, I'm going to say negative 3/2 x plus 7. Again, once you've solved for y, all you really care about are the slopes. Okay, you don't care about anything else. You want to make sure the equations are solved for y, and once you do that, you're just going to focus on the slopes. Now, we said when we're talking about parallel slopes, they're the exact same from equation to equation. But now we're talking about perpendicular. And for perpendicular, what we want to see is whatever the slope we see in the first equation, for the other equation to be perpendicular, you have to flip that slope and change its sign. So we're looking at 2/3 right now. So if I flipped it, it becomes 3/2. 2/3, if you flip it, becomes 3/2. It's inverse. It's reciprocal. It's 3/2. Okay? Now, it was a positive 2/3 up here. Now it's negative. So I flipped it, 2/3, 3/2, and I changed the sign. Positive to now negative. So in order to be perpendicular, you have to flip and change the sign. Show you another one. Y equals negative 3x plus 4, and y equals 1/3 x minus 3. Again, once we've solved the equations for y, all we care about are the slopes. And so my first slope is a -3. Now 3 is really 3 over 1. So if I flip 3 over 1, I get 1 over 3. So if I flip this, I get 1 over 3. Okay, which is what I have here. Then I had a negative, and now my slope is positive. So I also have opposite signs. So flip and opposite signs means that you're dealing with perpendicular slopes. Okay, so it has to be the flip and opposite sign. Alright, and if it doesn't fit either one of these criteria for parallel and perpendicular, then you would say neither. Alright, so now let's look at the problem we have here for number 11. The first equation, let's see, we want to solve it for y. So we want to add 7x to both sides. So that would be -6y equals 7x plus 6. Alright, because I added 7x to both sides. And then for the other one, we're also going to add 7x to both sides. That leaves me a -6y equals 7x plus 2. So I added 7x to both sides. Now I have to divide -6 from everything in both equations. So let's move up here. -6y equals 7x plus 6, and the other one is -6y equals 7x plus 2, and we're left to divide everything by -6. So this one is going to become y equals -7 over 6x minus 1, because you're going to say this 6 divided by this -6 is going to give us the -1. That's where this -1 comes from. Okay, and now we're going to do the second equation, divide everything by -6. So y equals -7 over 6, and that's minus 1/3. Keep my x. Okay, so again, now I've solved both equations for y, and once I do that, my focus shifts solely on the slopes. I'm looking at the slopes, and I notice my slope here in equation 1 is the exact same as it is here in equation 2. Therefore, I'm looking at parallel slopes. Okay, so these two lines would be considered parallel. Alright, that concludes our review. Hopefully I've given you some information that will help you better understand graphing. I know it's an issue that many students struggle with. So hopefully, again, this is information you can use to help you be a little more successful at graphing linear equations. That concludes our review. Thank you.